This is the poorly named Wiggers diagram. It was named after Carl J. Wiggers. So anyway, that's why it was named. But it's a really important diagram, and it shows the relationships between a lot of different things in cardiovascular physiology. So just to kind of start out, the x-axis, there's only one axis, and it's time. And time's going in this direction here. And then the y-axis, there's a lot of them. There's aortic pressure, there's ventricular pressure, atrial pressure, ventricular volume, the ECG is on here, and then you also have the heart sounds. So just to kind of go over some key points, because this diagram is heavily tested. It's usually tested with the pressure volume loop, but you need to know certain things and certain principles to apply them to test questions. And so let me circle a few points here. So at each of these points, something happens. And the reason why is kind of important to understand. So right here it says mitral valve closes. Well, why does the mitral valve close? It's because the pressure in the ventricle has exceeded the pressure in the atrium on the left side of the heart. We're always, whenever we talk about this diagram, we're usually talking about the left ventricle. So anyway, so the mitral valve closes is because the ventricle is contracting, and you can see from here to here, this would actually be isovolumic, iso meaning the same, volumic volume, same volume. And so nothing leaves the ventricle until this point right here that I circled, and that's where the ventricular pressure goes above the aortic pressure, and now the aortic valve opens and the blood is ejected out into the aorta, and then the blood continues to be ejected until when the aortic valve closes. Why would it close? It would close because the pressure in the aorta is higher than the pressure in the left ventricle, and that happens right here. And so one of the things you notice is that that point is higher than this point, and the reason why is because the aorta, as blood is being ejected into it, it takes up that blood and it stretches out, it has compliance, and by taking up that blood and having that compliance, it's storing energy of that blood, but it's also creating a back pressure, and so that back pressure makes it harder to keep that valve open, and that's why we have a higher pressure when it closes. So this is an isovolumic period also. Isovolumic, same volume. Isovolumic relaxation. It relaxes all the way down to here, and then the mitral valve opens again. And if you remember, the atrial pressure is very, very low compared to the ventricular pressure. And so the ventricle has to relax all the way down to here. And you can see there's just a little bit more pressure in the atrium than the ventricle, but that fills the ventricle. And then you have, this is an important thing, the A wave. That is atrial systole. That's when the atria is contracting at the end of diastole. So I said atrial systole, that's what it's referred to, but it takes place during diastole. And so, and then the cycle starts again. So, and you can see that everything, if you just kind of take this line and go down, you can look at everything else. The first heart sound, a little bit counterintuitive, but it actually, the first heart sound, that's the beginning of systole. Okay, the second heart sound, that's the beginning of diastole. Okay, you would think it would be the other way, but it's not. The third heart sound, which we'll talk about later, is pathologic. It's in the middle of diastole. It's the blood rushing into a dilated ventricle. The fourth heart sound, if it's going to take place, it would be right here, be an atrial kick. So this is where the fourth heart sound would be, which I know we'll be talking about later. And you can look at volume here. Volume makes sense. Remember I said that there's two isovolumic periods. It's this period here and this period here. They're both isovolumic. This is peak, PIP, comes up a lot, peak isovolumic pressure. It comes up a lot, so I'm sure we'll be talking about it. But anyway, great diagram to go over. Just try and understand what's going on, and this will play into a lot of the questions that you might get asked.